So now we're going to continue with the transformations of periodic functions, but now we're going to talk about horizontal compressions and stretches. So as a reminder, what we have is the generic form is going to be f of x is a sine k x minus c plus d. And the one we haven't talked about, of course, is this one over here. It's going to be our k value. And so we're going to talk about how we could figure out what that k value is. But first of all, we're going to go back and quickly talk about the regular graph and the period. So we have, in a normal sine graph, what we have is, it looks something like this. And what we've said before is that the period, so it's going from one point, so one full cycle is going to be the period. And for a sine graph or a cosine graph, the period is 360 degrees. It's going to be, and if you could also do it from middle to middle or from top to top or from bottom to bottom. Now what I'm going to do is I'm going to divide it up into segments, because what we care about is we care about our points. And if you remember, the points were at 90, 180, 270, and 360. And so what we have is we have this distance over here. And this word I'm going to say is not a real word. This is a word I've made up, but I'm going to call this a segment. And so a segment is essentially just a quarter of the period. So each of these points is going to be a quarter period away, or a segment away. So if we were going to have a formula for it, the segment would be the period divided by 4. So for example, normally for a regular sine graph, the period is 360, and the segment is going to be 360 over 4, which is 90 degrees. Okay. So let's say we have, we'll call this example 2 now. Let's say we have f of x is sine of x minus 15. So the period, there's no k value here. Well, there's a k value of 1, so there's no special k value over here. So the k value, not the k value, the period is going to be 360. You can see that the k value is 1. Well, maybe we'll mark that in. And a segment is going to be 360 over 4, which is 90. So if I'm going to graph this thing, well, I've moved right 15, so I'm going to start at 15, and then I'm going to go up by the segment, which is 90. So I go by 90, and we've already done this. So I went by 105, 195, 285, 375. And therefore, and it's a sine graph, so it starts in the middle, goes up, goes down, goes there, goes there. I was going to go backwards. It would be minus 75, I think. I hope that's right. And if we calculate the period, so the period is going to be between, say, maybe from the bottom to the bottom. So from negative 75 to 285, the period is 360 degrees. Or we could go from middle going up to middle going up, and it's still 360 degrees. Okay. Now, what we're going to do is we're going to come up with a formula for k. We're not going to come up. I'm just going to give you the formula for k. So the formula for k is going to be this. So the period, so remember, if k was 2, let's just quickly, actually, before we say that. So let's say we had f of x equals sine of 2x. what we have over here is a horizontal compression. It's inside the bracket, it's a horizontal compression, which means it's going to be squished in together. Which means that the period used to be 360, but now it's going to be something less. So the period is going to be 360 divided by k. The bigger the k, the more of the horizontal squish we're going to have on the period. And if you rearrange this formula, you would get that k equals 360 divided by the period. So it can go both ways, right? Let's actually graph that f of x equals sine 2x. We might need to have a new sheet for that one. So it's going to go, we're going to graph, so this is example 3 now. So f of x equals sine of 2x. And we'll say, okay, so k equals 2. The period is going to be 360. Wow, that's a horrible 2. That's a 2. 360 divided by 2, which is 180. And we're going to need to figure out what a segment is, and the segments are going to be the period divided by 4, which is going to be 45. Okay, so how are we going to use this? So we know that the sine graph normally starts at 0. It goes as high as 1, as low as -1. And now what we have is, instead of going up by 90, each segment is going to be 45. So it's going to be 45. Another 45 is that. Another 45 is that. Another 45 is that. And another 45 is like that. And then we have our points. It's a sine graph, so it starts in the middle going up to the bottom, like this. And it's going to be like so. And that's the graph of f of x equals sine of 2x.